3 equal parts. Yeah, so let me first try to explain the problem, and then we're gonna try to find a method to solve the problem. Yeah, so let's first try to understand it. So we are given an array which consists of only 0 and 1s. So we are sure that the array gonna be 0 and 1s. So we're gonna use the first example. So in an array, we're gonna have like 1 0, 1 0, and 1. So we only have 0 and 1s. So what are we gonna do? We're gonna divide the array into 3 non-empty parts, such that all of those parts represent the same binary value. So let's try to split it. So maybe let me just use another color. Yeah, so maybe we can split it from here. So this is one part from the left side, and let's just split it for another part, maybe from here. For the right side, it's another part, and in between, in the middle, this is the third part. Yeah. So for each part, the binary representation gonna be the same, because for the first one the value is 1, and for the second part the value is 1 as well, and for the third one the value is for 0 1, the binary value is also 1. So this means they are equal. So this is one possible splitting. So if we can find it, so we're gonna just return. So for this example, we're gonna return, I think it is 0 and 3. Let me check. Yeah. So for this example, we're gonna return 0 and 3. Yeah. So 3 gonna be here. This is the index 3. Yeah. So this means from something to 0, this is one part, and from index 1 to 3 minus 1, index 2, this is the second part, and from the index 3 to the end, it's gonna be the third part. Yeah, so this is the splitting, and we need to understand these areas. So from array 0 to array I, so array I equal to 0, so from anything to array 0, it means this is the first part, and then I plus 1, it's gonna be here. Yeah, it's gonna be from 0 to z minus 1, and z is 3, so z minus 1, it is index 2, so it means index 1 to 2, it is the second part, and after that, from index j, it's going to be the third part. If we cannot find it, so for example, we only have 1 and 1, maybe 0 and 0, we cannot split it because there are only 2 ones, so we're going to return minus 1 and minus 1 directly. Yeah, so the idea is that how can we split it? Let's just try to use this first example. So from here, definitely, we need to find how many ones. Yeah, because for the binary representation, for each part, the number of ones must be the same. So for example, each part we have only 1. For the number 1, we have only one value of 1, and for this part it is also 1, and this is also 1. So it means we're gonna count the number of ones. If modulo 3 equals to some value, maybe 1 or 2, definitely we're going to return a minus 1 and minus 1. This means it is not possible. Yeah, so otherwise, if modulo 3 equal to 0, if the number of ones modulo 3 equal to 0, this means it can be a possible answer, but we need to check that. And for checking the final result, let's just try to use some better idea. Maybe we have 1 1 and 0, in between there are some numbers, and then we're going to have 1 1 0, and in between there are some numbers, and then we're going to have 1 1 0. Yeah, so if we have a valid answer, definitely if we find the first one, we're going to find a pointer, it's going to be p1, and then we're going to find the second pointer, which is going to be p2. But how can we find it? Just imagine this example. All other areas, just imagine it to be 0. Yeah, we just need to count how many ones. 1 2 3 4 5 and 6 ones. So 6 modular 3, and 6 divided by 3 is going to be 2. Yeah, so if we find 2 ones, it means for the next number it must be p2. And if we find 4 ones, for the next number it must be p3. Yeah, so we find 3 pointers. Now we are going to check those 3 pointers. If they are equal, p1 equal to p2 and p2 equal to 3, so we're going to go to the next. Yeah, so the p1 going to be here, and p2 going to be here, and p3 going to be here. Yeah, and if they are equal, so we're going to move to the next. So p1 and p2 and P3, they are still equal. And what about next? Next, the P1 gonna be here, right? This gonna be P1, and P2 gonna be here. Although it is a 0, it is okay. Yeah, so this is P2, and P3 will go out. Let's just check the length of the array gonna be n. Yeah, so if P3 equals to n, it means go out of the range. We're gonna add the while loop. But we need to find where we need to cut it. So this is P1. It means P1 should minus 1. Yeah, P1 minus 1 is going to be at this position. And what about P2? And from the P2, we can just use this P2 because we need to have such kind of a 1, 1, 0. So we need to have this P2. Yeah, because P1 minus 1 should be here, because after that, we first check this one, gonna be P1 minus 1. Yeah, but after that, we need to use this P1 plus 1. It's gonna be this value. So this is why we're gonna use P1 minus 1 as our final P1, because this P1 gonna plus 1, that's gonna be the second part. So the second part gonna be P1 minus 1 plus 1. It's gonna be P1 to P2 minus 1. Yeah, so this is going to be P2 minus 1. It's going to be here. So this is going to be the second part. And after that, from P2, it's going to be the third part. Yeah, so this is going to be like how can we solve the problem. But even this is okay, but we have to check there should have no overlap. I mean, for the first part, while we are using the while loop, it cannot have the overlap with the second part or the third part. Yeah, so we have to check the P1 should less than the origin. Let's use O of P2, origin of P2, and also P2 should less than origin of P3. Yeah, and also for the pointer P3 should less than n. So this is the boundary check we have to check. Otherwise, if there's an overlap in between, it is not the valid answer. Yeah, so for each part, there should have no overlap. So this is why we're going to use this kind of a formula, to check there should have no overlap. So if everything's okay, we're going to return the P1 minus 1 with P2. Otherwise, if they are not equal, we're going to return minus 1 and minus 1. Here, not equal, I mean P1's value not equal to P2's value, or P2's value not equal to P3's value. So we're going to return a minus 1 and minus 1. Yeah, let's just continue. If there's something misunderstanding, I will just go back to explain it. Yeah, let me just continue the coding. So we're going to check the number of ones. So we can use the count array.count. We're going to count how many ones. So if ones equal to 0, this means if there's no 1. So for example, if it is always to be 0. Yeah, but the array going to be at least 3. So what are we going to return? And we're going to return this part. This is going to be 0, and we can also return this part. This is going to be 2. So it's going to be 0 and 2. Basically, this means 0 is the first part, and 0 plus 1, and 0 I plus 1 to j minus 1. This part, this is going to be the second part, and from j, it's going to be the third part. Yeah, but how can we return? We can return 0 and n minus 1. So n gonna be the length of the array. Yeah, because we're gonna use the length of the array later. So I gonna define it to be the length of n. Yeah. Now we're gonna check if 1's modulo 3 equal to some number. It means it is not possible. Yeah, we're gonna return a minus 1 and a minus 1. Otherwise, it's gonna be possible. So we're gonna prepare a target value, maybe a target value equal to 1 and divided by 3. So this is going to be our target value. And then I'm going to prepare 3 pointers. So P1 equal to P2 and equal to P3 and equal to 0 from the beginning. And I'm going to also prepare a counter. So the counter is going to be 0 from the beginning. Now I want to find the pointers of P1, P2, and P3. Yeah, so this is why. How can I find this is P1 and this is P2 and this is P3. Yeah, so if there is a possible answer, definitely I would to find the starting point of P1, P2, and P3. But how can I find it? I can just enumerate the array. So for I num enumerate the array. So if num equals to 1, so this means I'm gonna start from here. Yeah. So if I find the first one, this is gonna be P1. So I'm gonna start here. Yeah. So P1 gonna be equal to I aleph. Yeah. So here is num equal to 1. I need to check the counter. So if the count equal to 0, so I'm gonna start from here. Yeah. P1 gonna be equal to I. Aleph is this count equal to the target. So the P2 gonna be equal to I. So aleph, the count equal to target times 2. So the P3 gonna be equal to I. After that, I'm gonna increase the count. Yeah, so I cannot increase the count from the beginning after here, but I need to increase it from here. Yeah, this is how I can split it into 3 parts like that. Yeah, because basically from here there are 6 ones, and from here I find 1 and it is a 2. Yeah, but basically the count is increased after all my calculations. So this means if this num equals to 1, my count is still 0, but after that my count is going to become 1. And then I find another 1, so my count is 1. And then I find another 1. Currently the count is 2. It's not 3. And then I'm going to set my pointer P2 equal to I, and this is going to be this position. And then after the calculation, I'm going to increase my count. So this is why we're going to increase count at the end. Now we have the pointer of P1, P2, and P3. We just need to check the result. As I said before, I'm going to prepare a region because I need to know the fixed positions of P2 and P3. So I'm going to prepare a region P2 and a region of P3. So I'm going to set it to be P2 and P3. Now I'm going to use a while loop to check if it is possible, if there would be a possible answer. So from P1 should be less than the origin of P2, and P2 gonna be less than the origin of P3, and P3 gonna be less than n. This is the length of the array. Now we are going to check if array P1 not equal to array P2, or array P2 not equal to array P3. Yeah, so I'm going to check it if they are not equal, so I'm going to return a -1 and a -1. So let's just check the example. So if this value not equal to this value, I'm going to return a false immediately. It's going to be -1 and -1. Currently it is equal, but if it is not equal, I'm going to return a -1 and -1 immediately. So otherwise, if I didn't return the false value, so I'm going to update the P1, P2, and P3. So finally, I can return the final result. As I said before, it's going to be P1 -1 with P2, but I have to check if I have finished all the while check. I mean, I finished the pointer of P3, this one, and this one. It means the pointer of P3 must equal to n. Yeah. So if P3 equal to n, I'm going to return P1 -1 with P2. Otherwise, if I cannot return like that, I'm going to return a -1 and -1. Yeah. So this means even I didn't return a -1 from here. Maybe the example is like this. Here we have 1 1 0 or some values, or here we have 1 1 0, but here we don't have a 0. But how can we cut it? So this means we cannot cut it. Yeah, because even we cut it from somewhere here, it will be bigger than this value, because this value is just 1 1, and here maybe 1 1 0. If we cut it from here, it's not possible because here we have another zeros. So this means for the P3, it must be equal to n, and then it's gonna be valid. Otherwise, it will not be valid. So we're gonna return a -1 and a -1. Yeah, so this is gonna be the entire code for this problem. It's a lot of coding, But the idea is not so difficult. Normally, we should think about this idea, even we cannot solve it, but at least, yeah, we have an idea. It's gonna be helpful for us to solve the problem. Now, let me just check why it is wrong. Yeah, let me just print out the P1, P2, and P3 to check if there's something wrong with it. Yeah, so here my output is just 0. Definitely, it is wrong. Yeah, because here I didn't use the single equal. I used the double equal. Definitely, it is wrong. Let me check. Now my P1, P2, P3, it seems yeah, it seems okay, but it's not the final result. I have to check. If array P1 not equal to array P2 or array P2 not equal to array P3. You see, I did some typo. It should be P3, not P2. Yeah, because array P2 not equal to array P2, definitely it's gonna be wrong. Now it is still wrong. Let me check maybe some other errors. And for this example, this is a 0, and this is a 2. This is gonna be 3, gonna be 0, 3. Yeah, let me just check why. I called how many ones. This is the length of the array. If 1 is equal to 0, I return the final result. Then if modulo 3 equals to a value, so I'm going to return a -1 and -1, and then I have the target, and P1, P2, P3, and I have a counter, and this P1, P2, and P3. If this is a P1, so this is a P1, and this is a P2, and this is gonna be P3. Yeah, it seems okay. 0, 2, and 4. And then I'm gonna check it will go to this position, and it will go to this position, and it will go out of the while loop. And here this gonna be 0, and P2 this gonna be 3, 0, 3. Yeah, it should be okay, but I didn't return the final result. I think there must be some mistake from here. Yeah, here I think there's another typo. Yeah, because this arisen P3 should be equal to P3, but I did type a P2. Yeah, let me just run it. Yeah, as you can see now it works, you know. Yeah, because of the coding is much longer than other code, so this means we're gonna, yeah, we are very easy to make a lot of mistakes, and we have to find where it is. Now luckily for me, I found there's a typo. Yeah, it's a mistake. Now let me just submit it to check if it works. As you can see, it works, and it's pretty fast because the time complexity is just O(n), and n is the length of the array, 3 times 10 to the power of 4, because in the whole coding we didn't use a nested loop, we only used one loop to solve the problem. And this kind of problem, I think we're going to call it a simulation. We just need to understand the problem, and then we're going to simulate the problem. Yeah, so that's for it today. Thank you for watching. See you next time.